All right, let's go ahead and try some of these. I believe I'm doing numbers 35 to 37, and for homework, you do 38 to 40, 38, 39, and 40. We'll start off with number 35. We're going to match the linear system with its graph and tell how many solutions it has. All right, let's see which one represents 35. Let's first to see if they're multiples of each other. Can I multiply this to get anything? No, so this is not a multiple of each other, so we know that it's not going to have infinitely many solutions, meaning it won't just be one line. So let's go ahead and see what else. Will it be parallel? Remember, parallel, your x and your y's will be multiples of each other. So you can already kind of deduce that this will have a unique solution. Just because it doesn't satisfy the properties as we saw over here, right? You want to study that out. Because it don't have those properties, we can already see that this will have one solution. So let's go ahead and see which one actually matches to. And most times just finding one can help you. But let's start off with the easier one. The x-intercept here, if you set y equal to 0, would be 0. And the y-intercept would also be 0. All right, so which one will we have where the x is touching at 0 and the y is touching at 0? If you see it already, then you can go ahead and pick it. If not, you need to find the x and y intercepts of the top one, then let's do that. To find the x-intercept of the top equation, x is equal to negative 5. If you set y equal to 0, it would be negative 5 over 2 or negative 2.5. And that should be negative 2.5 if you can make it out. So do you see where x is touching at negative 2.5? All right, and then for your y, if you set x equal to 0, you have negative y equals to negative 5, or y is equal to 5. So that's what we're looking for, x-intercepts of that nature. Now, if you look around here, we're first of all looking for parallel for first of all we're looking for where they intersect. So we can kind of deduce that it's not A, it's not B, and it's not F. So it has to be either C, E, or D. So let's look for those intercepts. For the first one in the blue, do we see something intersecting at x equals 0, y equals 0? Right there. And then x equals negative 2.5 and 5? Right here. And actually, that is the solution as well to the equation. But for this one, E is the answer. And then it's one solution. So that's our one. E is the correct answer there. All right, so for 35, we have E and one solution. All right, so for number 36, we know that it has to be either A or B. Sorry, not A or B, A or F. It has to be parallel because we see that these are multiples of each other, but these two are slightly different in terms of the multiples. The other two, they're multiples of negative 1, and then this one's a multiple 2. So that means that it has to be, based off of our understanding of linear systems, that those have to be parallel. All right, so let's go ahead and figure out which one. We could do the x and y intercepts, or we could change it into slope intercept form. Since I did x and y intercepts over there, I guess I could do y intercept for this one. So if we did y-intercept, remember I just did it really fast. We're going to have 3y is equal to negative 2x plus 12. And then if we divide everything by 3, we're going to have negative 2/3 x plus 4. All right, so that means we have a y-intercept of 4. And bam, you already see it right there. And if we go down to 1, 2, and over 3, we see that's our line. So you can assume already that the other one is the bottom one, and so this answer is F. But just to be on the safe side, I'll do this one x and y intercepts. If we have 2x equals to 6, then that means x must be equal to 3, y equals to negative 2. And do you see that? X is at 3, y is at negative 2. So we know for a certainty that F is the answer, and it has no solutions. 0 solutions or no solutions would be the answer for that one. All right, so there we have it. Number 36 is F, and it has no solutions because it is parallel. All right? That one doesn't want to erase. Okay, so that one is F, and we have 0 solutions. All right, so let's look at the last one, number 37. For number 37, we can look at this, and you can see that this one is a multiple of -2. If I was to multiply the first row, -2 times 2 is -4. -2 times the negative y is positive 2y. -2 times 5 is -10. And because they're multiples of each other, we know that they're the same line. And because they're the same line, infinitely many solutions. And so that means we're looking for one with one line, and there's only one with one line. So we know already that the answer must be B, infinitely many solutions. But we are going to do it the longer way as well. Doing it the long way is that I will try to see which graph this one matches. So we can do y-intercept, x and y-intercepts. So if I set my y equal to 0, I'm going to have, if I set my y equal to 0, for x, I'm going to have x is equal to 5 over 2, or 2.5. And if I set the x equal to 0 and solve for y, I have y equals to -5. That's for the first one. For the second one, if I do the same thing, set my y equal to 0, I have -10 over -4. And -10 over -4 is just the same as 10 over 4. And if you reduce that, that's 5 over 2, which is the same as 2.5. And then for the y, same thing. I have -10 divided by 2. So that's going to give me -5. And you see it's the same y-intercepts, 2.5 and -5. And so at the x, I'm looking for 2.5, which is here, and y, -5, which is there. And so we know for certainty, so that one is B, infinitely many solutions. So we had E at one solution. We had this one was F with no solutions. And then this one was B and had infinitely many. I'll just draw the infinite sign. Infinitely many solutions. All right, and so if you practice knowing the rules to it, you can actually get it done faster without any working. All right, let's go ahead and try an example in real life for using linear systems in real life. And so, of course, your understanding of being able to formulate a equation based off of the word question is really important here. So it says, and this is number 10 from the book. I forgot to put the page there, but your school is planning a 5-hour outing at the community park. The park rents bicycles for $8 per hour and inline skates for $6 per hour. The total budget per person is $34. How many hours should students spend doing each activity? All right, let's go ahead and formulate a linear system. So for this one, you can create a verbal model. Remember, we've been practicing verbal models in the past, so it's still the same concept here. You're going to want to figure out how to write out your verbal model. So you're going to need two equations, two linear equations. The first one could be in terms of time. I don't have control of the pen, so the first one should be in control of in terms of time. So you see you have a total of 5 hours, and then you have a total budget of $34. So you can have one linear equation representing your budget, right? And one way to find these is always look for the totals. It makes it easier. And the other one represents your time. So if I was to do the one with the budget, my budget is going to be $8 per hour for bicycles. So I can let X represent bikes, and I can represent Y to be skates. So for my budget, I have $8 per hour, and so that's 8X plus my 6Y, and that's going to be equal to $34. All right, so I can let my X represent hours for how much hours I spend for bikes, and then my hours for skates. All right, so let's write this one out for a budget. Of course, we're dealing with that which has the money. So that's $8 per hour for skates, and I mix it up. So 8y plus 6x. I meant to put the x first, but I'm not going to rewrite it. So 6x is going to equal to $34, right? Then I have the time. Well, how much time am I spending? Well, I'm spending X amount of hours riding bikes, and let me just keep it in line since I mixed them up. I'm spending Y amount of hours using skates and X amount of hours using the bikes, which would be a total of 5 hours. And that's the easiest way to do linear systems. Think about what is your total for each one, just find the totals and then set them up accordingly. So now in order to do this, we need to graph each of these linear systems or linear lines. So let's start off with the easy one, the time. X is equal to 5, right? If we were to do y-intercept, so X is here, and Y is equal to 5, Y is there. So that represents my first equation. A little bit off, but actually we need it to be on as much as possible because we're trying to see if they intersect, and if they do, exactly where. So there we go. That's our first one. And it's good to label these. So that's x plus y equals to 5. All right, then we do the second one. I'll change the color here. All right, because the 8y plus 6x equals to 34, it's not going to give us whole numbers. It means that I'll be estimating the intersection unless I had a ruler. And since I don't have a ruler, I'm going to change it into slope-intercept form to be on the safe side, and so that way I could count my slope down right down to the very bottom. All right, so let's go ahead and do that. We're going to change this. We're going to have 8y is equal to negative 6x plus 34, and divide both sides by 8. And so we're going to have y equals to, that's reduced down. If we divide both of these by 2, we're going to get negative 3/4 x plus 8 goes into 34 4 times, so 2 left over, so 4 1/4. And we could turn that into a mixed number again, but no need. Improper fraction, rather. So we're going to find 4 1/4. That's our y-intercept, which will be about here, halfway in between 4 and 4.5. And then we're going to go down 3 and to the right 4. So if we go down 3 from there, that's here, 1, 2, 3. And then over 4 units. So 1, 2, 3, 4 units. 2, 3, 4. So 4 is about there. All right, so this is where you really, really need a ruler for questions like these. Okay, so when I draw this out, I'm noticing that I'm getting two possible solutions here. And that's because I don't have a ruler. If you're using a ruler and a proper graph, you will know for certainty which one it is without having to do what I'm about to do now, and that's to check whether it's 2, 3 or 3, 2. So it's one of those ones. So this is either the point 2, 3 is touching or the point 3, 2 is touching. Once again, you want to use a ruler. It's very hard on these screens here to duplicate that. So just check it out. If I substitute into the time, you see 3, 2 works and 2, 3 works. So we need to see which one works for the budget, and I'll know for certainty which one should be touching the graph. So 8 times 2 is 16. Let's just do the first one. 8 times 2 is 16 plus 6 times 3. Does that give me 34? So we have 16 plus 6 times 3 is 18. And that does give 34. So more than likely, that is our answer. And the other one should not work. So that would be our answer. 2/3. 2 and 3, sorry. If we substitute 3 in there, 8 times 3 is 24. Yeah, that's not going to work because 2 times 6 is 12, and that'll give us 36. So this is where it should intersect, at the point 2, 3. So keep that in mind. Using a ruler for this is really important and vital, and it's difficult on my side on here, but for you it should be much easier as you don't have the restrictions of the screen. Okay, so let's go with one more. We here have another question, number 55 from the book, page 144. You are on the prom decorating committee and are in charge of buying balloons. You want to use latex and mylar balloons. The latex balloons cost 10 cents each and the mylar balloons cost 50 cents each. You need 125 balloons and you have $32.50 to spend. How many of each can you buy? Use a verbal model to write and solve a system of linear equations. All right, so let's go ahead and do this one step by step. Remember, first you need to come up with an equation. You could use L and M for your latex and mylar, or you can use X and Y. I just like to stick with X and Y. So number 55, it says, okay, you're dealing with cost and the amount. So very similar to what we did before. I'm going to need a cost function or linear equation to represent the cost. And so I have the cost, X can be the cost of the latex. Latex balloon, I also put a Y there. And then Y could represent the mylar balloons. And that's the cost. Or no, that's the amount. So the amount of latex versus the amount of mylar. So the cost would be 10 cents for the latex balloons plus the cost of the mylar balloons, which is 50 cents. And that would be equal to $32.50. That's my total. My other total is the amount of balloons. So I'll just put here the amount. And the amount of the balloons will be, I have X amount of latex balloons plus Y amount of mylar, which would be a total of 125. And if we solve these simultaneously together, we get a linear system. So remember to see, well, whenever you deal with real life situations, you normally want a solution. So when we solve this, we are getting one since we're going to solve it. And so let's start off with the first one. We have x equals to 125 and y equals to 125. Now just glancing at it, I knew I needed something pretty long, and so my ones are going by tens. So basically I'm going to graph 12.5 to represent 125. And so let's go ahead and do that. So where 125 would be, it's going to be my 12.5. So that's 10, 11, 12. 12.5 would be about here for the x-axis. And then for the y-axis, 12.5 would be about there. All right, and so we'll connect those two. And as you saw before, a ruler is really important. That wasn't as nice as I wanted it to be. And if I wasn't on PowerPoint, they do have these line options. I'm surprised they don't have it on here. All right, so let's try to draw a line through this straight. It's better if you go fast. All right, so here that's our line, x plus y equals to 125 on the x-axis. All right, and then we need to draw the other one, and we can use x and y intercepts again. If we do the x-intercept, or you could do slope-intercept form, I'm wondering which one would be better for this scenario. They look like they should get whole numbers. So 3250 divided by 0.10 actually goes up higher. It's like multiplying by 10. So that's going to be 325 for the x-intercept. And then for the y-intercept of the first equation, I'm going to have to work this one out. 32.5, that's like the same as multiplying by 50. So let's see. That's going to give us 65. It's like multiplying by 2, by half. So we have, that's going to give us 65, I think I said. Yeah. All right, so we have our x-intercept there. And remember, we're going by tens again. So that's like 32.5 on my graph and 6.5. So my x-axis is 325. Or 32.5. So that's 31, 32. That's right near where I wrote x-axis is. So let me just erase it. So 30, 31, 32, 32.5 would be about here. Okay, and then for my y-intercept, 65 or 6.5 would be about there. That represents 65. All right, so then we're going to connect those two, and hopefully we get a nice connection. Because we're dealing with balloons, we have to have a whole number. And so it has to touch at a whole number intersection, or else it's not going to be correct. All right, so let's go ahead and try to maneuver this. I'm just trying to look to see how I can draw this line nicely. All right, that I should have did a different color, but I think that actually came out decent. So looking at my intersection right here, that's 5, 6, 7. 7 is the intersection, and about 5. And I'm thinking, because those are whole numbers, I'm thinking that might be pretty close to it. Actually, it's a little bit more than 7. I think it might be like 7 point something. 7, and because we're dividing by 5s and zeros, I'm thinking this is about 7.5. And we're going to try both of them out to see which one is the best. Now remember, with graph paper and with a ruler, you don't have to do any of this guessing. You get right to the answer. All right, let's go ahead and try it. I'm thinking that I have 7.5. It represents 75 latex. So 75 is going to be my X. 75 or 70. I think it's more, so I'm going with 75. And 5 is going to represent 50, right? Because we're times them by 10. So 50 is going to represent Y. And that's what I believe the answer is. And we're going to just substitute in there just to check. Uh, 75 plus 50 is indeed 125. So I believe that's it, because 70 plus 50 is 120. So I really think this is our answer. And we could just check that out. 0.10 times 75 plus, and it's not 0.10, that's a tenth, plus a 50th or 5 tenths times, what's my Y? 50 is equal to 3250. All right, 0.10, a tenth of 75 is 7.5, plus a half of 50 is 25, and does that equal to 32.50 hundredths? All right, so 7.5, that is correct. So that is our correct answer, right? And so just remember, with a ruler and with proper graph paper, you don't have to do this check, but it's always good to check your answers. So 75 latex balloons and 50 mylar balloons would be the amount that you want to buy so that you have enough money and a decent amount of balloons.